This is the first video on chemical bonding, and so this will be a hopefully brief introduction. And the first key piece is bonding occurs at the electron level. All bonding occurs with electrons. The octet rule comes into play, and the octet rule states that atoms are more stable when the valence shell has a noble gas configuration. You can attain a noble gas configuration by transferring electrons from one atom to the other, or sharing electrons between atoms. And there are three types of bonds that we're concerned with. The first is ionic bonding, and that's where electrons are transferred, covalent bonding, where electrons are shared, and metallic bonding, where the electrons actually become delocalized, and that's frequently called the sea of electrons. So let's start with ionic bonding. In ionic bonding, electrons are transferred from one atom to another. That gives each of the ions an electrical charge, so the bonding is the attraction between the ions, hence the term ionic. It is dichotomous. You have to have a cation, which are positively charged and is either a metal or ammonium, and you need to have anions, which are negatively charged and a nonmetal or a polyatomic ion. In ionic bonding, you do not get molecules, you get formula units, and they form a crystal. The strength of the crystal lattice is related to Coulomb's law because of the electrical attraction. And if this sounds familiar, it should. So if you need to review this, look at videos 19 and 20. Schematically, you can picture it this way. Here we have a sodium atom with 1 valence electron and a fluorine atom with 7 valence electrons. If the sodium loses 1 valence electron and the fluorine gains it, then the sodium ion will have 8 valence electrons and the fluoride ion will have 8 valence electrons. Because they are oppositely charged, they are attracted to each other, and they form the compound sodium fluoride. Let's move on to covalent. Covalent bonds occur between nonmetals. The electrons are shared. For reasons you'll see, now you can form molecules, and sometimes covalent compounds are called molecular compounds. Covalent compounds do not dissociate when dissolved, and thus they are frequently called non-electrolytes. And there are three types of covalent bonds. A single bond, where 2 electrons are shared, a double bond, where 4 electrons are shared, or a triple bond, where 6 electrons are shared. So schematically, let's look at 2 fluorine atoms. And remember, fluorine is one of the diatomic elements. One fluorine could give up an electron to the other fluorine, so this fluorine cation now has 8 electrons, or a noble gas configuration, but this fluoride ion now has 6 electrons. That is not noble gas configuration. This is not going to work to satisfy the octet rule. But if the 2 fluorine atoms happen to share a pair of electrons, then what you see is this fluorine now has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons, and this fluorine has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. By sharing the electrons, they now both achieve a noble gas configuration. This is kind of bulky to write out all the electrons. This is where the Lewis dot structures come into play. We start by drawing the Lewis dot structures for both fluorines. We see that they have 7 valence electrons each, and we say that those electrons can be shared, and pairs of shared electrons can be represented by a solid bar, and we would say that this is the Lewis dot diagram for the fluorine molecule, and so this is called a single bond. Why did we pick the 2 singletons? When we drew out the original Lewis dot diagram, we had 3 pairs of electrons. When you already have pairs of electrons, they are called a non-bonded pair, and non-bonded pairs do not get shared. So let's move back one from fluorine to oxygen. Oxygen has 6 valence electrons, so it has 2 singletons and 2 pairs. It can share those sets of electrons, And so you would draw it out like this. Each line is 2 electrons. We would call this a double bond. In nitrogen, we see that each nitrogen has 1 non-bonding pair, but 3 single electrons. Those 6 electrons could be shared, so you would draw 3 lines and call that a triple bond. Now there are some variations between the types of bonds. One is in bond length. A single bond is longer than a double bond, is longer than a triple bond. And remember, bond length depends upon distance between the nucleus. How strong the bond is. A triple bond is stronger than a double bond, which is stronger than a single bond. Now, in covalent compounds, the atoms are bonded to specific other atoms. This is called the structural formula because it shows you where the elements are located in the molecule. And in this case, this hydrogen only bonds with that carbon. This oxygen is connected to this carbon and to this hydrogen specifically. It is not related to the other carbon. Now remember, each bond line equals 2 electrons. So we can look at this hydrogen, and it has 1 bond. That means it has 2 electrons, and that's a full valence shell for hydrogen. And that's true for each of these hydrogens. So the hydrogens all meet the octet rule. Take a look at this carbon, and it has 2, 4, 6, 8. Its valence shell is filled. It has 8 electrons. The octet rule is satisfied. This carbon, 2, 4, 6, 8. The octet rule is satisfied. And last but not least, the oxygen, 2, 4, 5, 6, 7, 8. The octet rule is satisfied. The ratio of atoms in a covalent or molecular compound does not have to be the lowest whole number ratio. And electrons do not have to be shared equally. We'll deal with that in some videos down the line, and that's because of electronegativity. So now the third type of bonding, metallic bonding. It occurs obviously amongst metals and really occurs amongst metals of the same type. The valence electrons are loosely attached to the metals. That means they can move freely around the metal, and that's why it's called a sea of electrons. And pictorially, you can see it here with the pink positive cores and the blue valence electrons, and those electrons can move all around the pink. And it's that ability of the electrons to move around that allows metals to conduct electricity. So those are the 3 types of bonds. So to review, you have 3 types of bond. Ionic, where electrons are transferred, covalent, where electrons are shared, and metallic, where you have delocalized electrons, or the sea of electrons. In ionic bonding, it's based on ions. Think of the name. So there's an electrical attraction between the ions. Coulomb's law will come into effect, and specific cations are not linked to specific anions, and vice versa. So we have what are called formula units, lowest whole number ratio. In covalent compounds, electron pairs are shared. When drawn out, each line between 2 elements represents a pair of electrons. There are 3 types of covalent bonds: single bonds, where 1 pair of electrons are shared, double bonds, where it's 2 pairs, and triple bonds have 3 pairs. There is no such thing as a quaternary bond. The length of bonds between single, double, and triple are not the same. A single bond is longer than a double bond, which is longer than a triple bond. And for bond strength, a triple bond is stronger than a double bond and is stronger than a single bond. Electrons do not have to be shared equally, and this is where electronegativity comes into play. For metallic bonding, you have the sea of electrons, and that's all I have to say about that. So that's our introduction into bonding. In the next video, we're going to talk about how to draw the structural formulas for covalent compounds.